Good afternoon, students. Again, I am going to continue our topic, differentiation. I am going to again explain the logarithmic differentiation. Earlier, before vacation also we have done it, but it is one of the important topics, so I am just repeating it again. Now, the term is here, the logarithmic differentiation. Now, it is done. When it is done when the product or the quotient of more than two functions is given. Number one condition. Number two, if in the problems containing a function with the power of another function, then we have to take help of always the logarithmic differentiation. In such cases, we first take logarithm to the base e both sides, and then we should differentiate and find out the value of dy by dx. In which question we apply? When you have to given the product and the quotient of more than two functions. It is given the product and the quotient of more than two functions. Similarly, it is given the product of three functions. And here the one function is the power of another function. Then in all these type of questions, we have to take help of what? Logarithmic differentiation. Let us see here how to apply in the question. The question is differentiate y equal to sine inverse x whole power x. Now it is one function is the power of the another function. So we have to start the question by taking log both sides. Now taking log both sides, it is what? Log y, it will be what? X log sine inverse x, using the properties of logarithm log m raised to power n equal to what? N log m. So taking log both sides, it is what? Log y equal to x log sine inverse x. Then differentiating with respect to x. The derivative of log y is 1 upon y into dy by dx. Now differentiate it, we have to apply the product rule. The derivative of first function, the derivative of x is 1, second function as it is. Then first function as it is, the derivative of log sine inverse x. We have to use the chain rule here. The derivative of log sine inverse x, it is what? 1 upon sine inverse x into derivative of sine inverse x is 1 upon under root 1 minus x square. Now here, what do we have to find out? Dy by dx, taking this y to another side. So dy by dx equal to y into log sine inverse x plus x upon under root 1 minus x square into 1 by sine inverse x. So putting the value of y that is given in the question, we are getting the value of what? Dy by dx. So this is known as what? Logarithmic differentiation. Let us apply to another question. Again, it is a similar question. We have to find out the derivative if sine x whole power y equal to x plus y. Again, the one function is the power of another. So we have to start it by what? Taking log both sides. Now here, when we are taking log both sides, the left hand side can be written as y log sine x is equal to log x plus y. See this step very much carefully. You can't write log x plus log y. We have to write here y log sine x and right hand side log x plus y. Now again differentiating with respect to x, applying the product rule here on the left hand side. Now we are getting here the derivative of first function is dy by dx, second function as it is. Then first function as it is, the derivative of log sine x means 1 by sine x into derivative of sine x is cos x. Similarly, on the right hand side, the derivative of log x plus y. The derivative of log x plus y is 1 upon x plus y into derivative of x plus y. Then again simplifying dy by dx log sine x plus y cos y sine can be written as cot x is equal to 1 upon x plus y. Not the derivative of this. The derivative of x is 1 and the derivative of y is dy by dx. Then simplifying both sides and collecting the like terms on one side. Now the collecting on the left hand side the term containing dy by dx from both sides, dy by dx log sine x minus 1 upon x plus y is equal to 1 upon x plus y minus y cot x. Then simplifying taking LCM, simplifying both the side, left hand side as well as the right hand side, and getting the value of dy by dx equal to 1 minus x plus y into y cot x upon x plus y into log sin x minus 1. Let us see another question, one of the important question here. You have to find out dy by dx if y equal to sin x whole power x plus sin inverse under root x. This is one of the important question. Now here one function is the power of another and the second one is the simple function. Because one power is the function of another, it means we have to take log here. But see it very much carefully. First we have to write let y equal to u plus v. This is a very much important step. You can't take if there is sign of plus and minus. We can't take log both sides because we are not having any result like that log m plus n equal to log m plus log n. So we cannot do this step here. We have to start the question. How? Let y equal to u plus v, where u is sin x whole power x and v is sin inverse under root x. Therefore, to find out dy by dx can be written as du by dx plus dv by dx. Now from this u and v individually we find out what? Du by dx. Now to find out du by dx, u is sin x whole power x. Again one function is the power of another. We have to take log both sides. Log of u equal to x log sin x. Again differentiating the left hand side. The derivative of log u is 1 upon u into du by dx because our differentiation is with respect to x. Now the derivative, again you have to use the product rule here. The derivative of x is 1 second function as it is plus x as it is the derivative of log sin x. 1 by sin x into derivative of sin x is cos x. Simplifying and taking this u on this side, we are having du by dx equal to u into x cot x plus log sin x. I have arranged the terms here. Now putting the value of u here, it is what? Du by dx sin x whole power x into this term. Similarly, v is sin inverse under root x. We have to find out directly. We can find out the derivative by using the chain rule and using the derivative of inverse trigonometrical function. Therefore, dv by dx is 1 upon under root 1 minus x square. Now our x is what? Under root x. So 1 minus under root x square into derivative of under root x. So it is 1 upon under root 1 minus x into 1 upon 2 under root x. Now putting this value of du by dx and dv by dx because we have to calculate dy by dx. Then dy by dx is du by dx plus dv by dx, putting these values and we are getting the value of what? Dy by dx. Here I am collecting these because these are the like terms, we can easily multiply. So it is 1 by 2 under root x minus x. Now let us see another question. Now the question is find dy by dx if y equal to under root x raised to power under root x raised to power under root x raised to power under root x up to infinity. Yesterday also we have done the question of this type. Last time we have also done the question of this type. Now here again we are using the same point. These are the power of infinite similar terms. So we can take one term separate and the remaining term again can be written equal to y. This is only the important step here. So this can be written as y equal to under root x whole power y because the value of this is given to be y. I have taken only one term separate. These are the infinite term. It hardly matters. We can separate one term again. The remaining term again equal to y. So this can be written as y equal to under root x raised to power y. Now again one function is the power of another. Taking log both sides, log y equal to y log under root x. Again it can be written as y log under root x. Under root x is 1 by 2 power. So it can be written as y into 1 by 2 log x. Again differentiating both sides, the derivative of log y is 1 upon y into dy by dx is equal to taking 1 by 2 common and applying the product rule, the derivative y is dy by dx into second function as it is plus first as it is the derivative of second log x is 1 upon x. Again simplifying the term, collecting all the terms. I am collecting all the terms of dy by dx on the left hand side. Dy by dx common 1 upon y minus 1 by 2 log x is equal to y upon 2x. Simplifying here by taking the LCM and then finding the value of dy by dx equal to this. So then this is equal to y square upon 2x minus x into y log x. All these are the somehow the important question. Now see another question. The question is here, find dy by dx if x raised to power y plus y raised to power x equal to log. Again the sign of plus is there. We cannot take log both sides. We have suppose one function u, another function v, and then we have to start our question. Let u plus v equal to log. Therefore, this implies du by dx plus dv by dx equal to 0 because log a is the constant quantity. Its derivative will be 0. See this step again. We are starting it. We are supposing this is u, this is v. Let u plus v equal to log a. Therefore, we can write du by dx plus dv by dx equal to the derivative of log a will be 0. Now, from this we will find out what? Now u is x raised to power y and v is y raised to power x. Again by taking log both sides or by using logarithmic differentiation, we will find out the value of what? Du by dx as earlier we have done in the previous question. Similarly v equal to y raised to power x. Again you can taking log both sides, log of equal to x log y. Again we will find out what? dv by dx. Now we are getting the value of du by dx and dv by dx. Putting the value of du by dx and dv by dx in the first and simplifying here, putting the value of du by dx, dv by dx here and simplifying the opening the bracket and simplifying here. Then collecting the like terms, we are just because we have to find out dy by dx. Now collecting the terms of dy by dx on the left hand side and transferring the other terms on the right hand side. Then simplifying here dy by dx equal to this upon this. Now we can take here y common. We left with here when we are taking y common, it is what? Y into x raised to power y minus 1 plus when you take y common, it left with what? Y raised to power x minus 1 into log y. Similarly in the denominator again here what is common? X is common. We can take x common, we left with x raised to power y minus 1 into log x plus y raised to power x minus 1. This is all about today. Now today you have to do the practice of logarithmic differentiation separately. It is given in the element of mathematics. You just take the question from this very exercise and practice. This is all about